In the continuation of water chapter, today we will discuss the hardness of water and its determination. Hardness means it's a property of water by which it prevents the lather formation. Then two methods are there to determine the hardness of water. First is EDTA method or complexometric method, and second is soap titration method or Clark method. Water hardness is generally caused by the presence of calcium and magnesium ions in water. Some other polyvalent ions like strontium, iron, aluminium, zinc and manganese also contribute to hardness, but because of their very low concentration in natural water, hardness is generally measured as concentration of only calcium and magnesium ion. Then EDT, ethylene diamine tetraacetic acid. This EDTA is tetraprotic acid and it is represented as H4Y. Why it is represented as H4Y means it has 4 hydrogen ions which can be easily replaced, and this Y is the basic structure. And its disodium salt is generally used and it is obtained in the high state of purity, and its molecular weight is 372.124 and it's a primary standard. The solution of EDTA is very valuable titan because the reagent combines with metal ion in 1:1 ratio irrespective of the charge on the cation. The resultant complex have the similar structure but differ from one another in the charge they carry. We can see the reaction. M2 plus H2 Y minus, it's a disodium salt. Then how it reacts? M Y minus 2 plus 2 H plus ion. If we take the example of M3 plus, it reacts with the disodium salt which ionizes H2Y2 minus and form complex, that is My minus plus 2 H plus. The equilibrium is markedly affected by the pH of the solution. The complex of EDTA with divalent metal ions are stable in slightly basic solution. Then the structure of anion H2Y2 minus and its complex with divalent metal ion you can see in the diagram. Then what's the basic principle of this EDTA method? The quick, complete and 1:1 interaction of metal ion with the EDTA leading to the formation of stable complex is the basis of the complexometric titration. What's the theory of this experiment? The hard water is buffered to pH 9 to 10 using buffer solution, and there is the addition of Eriochrome black tea, it's a indicator, and there is a formation of calcium magnesium EBT complex. This EBT complex, calcium magnesium EBT complex, is wine red in color. When this wine red color solution titrated with the EDTA, calcium magnesium ions of this complex released and react with the EDTA and form calcium magnesium EDTA complex. This calcium magnesium EDTA complex is colorless and stable. And there is a release of EBT at the end point, so we are getting blue color. Then the procedure, chemicals which are required in this titration. First is preparation of standard hard water. To prepare standard hard water, 1 gram calcium carbonate dissolved in minimum quantity of dilute HCl, and then evaporation of this solution to the dryness, because we want to remove excess HCl from solution. Then dissolve the residue in 1 liter of water. Then preparation of EDTA solution. It's disodium salt, means disodium salt is used for the titration. 4 gram of pure disodium salt of EDTA is used. Then to preparation of 1 liter of solution. Then the preparation of EBT. To prepare EBT, 0.5 gram 0.5 gram EBT dissolved in 100 ml of alcohol, because this dye is alcohol soluble, it is azo dye. Then preparation of buffer solution. To prepare buffer solution, 67.5 gram of ammonium chloride dissolved in 570 ml of concentrated ammonia solution, and then diluted with the distilled water to prepare 1 liter of water. Then steps of this method. First step is the standardization of EDTA solution. Solution of EDTA which we have prepared, then how we can it standardize. To standardization, for the standardization, 50 ml of standard hard water is taken in conical flask. Then there is a addition of buffer solution and the addition of ureochrome black tea. After the addition of indicator to the solution, color of solution becomes wine red, and this wine red color solution is titrated with the EDTA solution, and the volume of EDTA consumed by 50 ml of standard hard water is denoted as V1 ml. Then determination of total hardness. Process will be same as the standardization, but in case we are taking water sample, 50 ml water sample is taken and titrated with the EDTA solution, and the volume of water sample, volume of EDTA consumed water sample is denoted as V2 ml. Then the determination of permanent hardness. For the determination of permanent hardness, first we have to prepare the water. For the preparation of water, 100 ml of water sample is taken in beaker, then kept it for the boiling for half an hour. After that, volume of water become reduced approx 50%. Then transfer this 50 ml water to the volumetric flask with the filtration, then make it up to the mark. Then this 50 ml boiled water is taken and titrated with the EDTA solution, and the volume consumed by this boiled water sample is denoted as V3 ml. Then the determination of temporary hardness. Temporary hardness can be found out by the subtracting of the permanent hardness from the total hardness, because total hardness, it means what? Permanent hardness plus temporary hardness. Then the calculation part. Then next is the calculation. Calculation, it means what? How to calculate the hardness of water. Then when 1 ml of standard hard water contains 1 milligram of calcium carbonate equivalent, it means to prepare the hard water, 1 gram calcium carbonate dissolved in water. So 1 ml of standard hard water contains 1 milligram of calcium carbonate. So if we are taking 50 ml standard hard water, it means 50 ml of standard hard water contains 50 milligram of calcium carbonate equivalent. So 50 ml of standard hard water consumes V1 ml of EDTA solution. V1 ml of EDTA contains 50 milligram of calcium carbonate equivalent hardness. So we can find out in 1 ml, that is 1 ml of EDTA solution contains 50 upon V1 milligram of calcium carbonate equivalent. You can see in the reaction. Then when 1 ml of EDTA solutions contain 50 upon V1 milligram of calcium carbonate, we can find out in hardness of the 1000 ml of water sample. It means when 1 ml of EDTA solution 50 upon V1, so 50 ml of hard water contains 50 upon V1 into V2, because V2 ml of EDTA solution consumed by the 50 ml of water sample. So 50 upon V1 into V1. So if we can find out 1000 ml, that is V2 into 50 upon V1 into 1000 upon 50. Then there is a cancellation of 50 upon 50, because this hardness is present in 50 ml of water. So we can find 1000 ml. So 1000 into V2 upon V1. So total hardness is 1000 into V2 upon V1 ppm. Now if we want to find out the hardness in boiled water sample, when 50 ml of boiled water sample treated with the EDTA solution, this solution consumes V3 ml of EDTA solution. When boiled water consume V3 ml of EDTA solution, when 1 ml of EDTA solution contain 50 upon V1 milligram of calcium carbonate, so 50 ml of boiled water contain V3 into 50 upon V1. If we want to find out in thousand ml, what will happen? V3 into 50 upon V1 into 1000 ml. This hardness is present in the 50 ml of water. So there is a cancellation of 50 upon 50. So what will be the next? That will be the V3 into 1000 upon V1. So total hardness in water is 1000 into V3 upon V1. Permanent hardness will be 1000 into V3 upon V1. This hardness is present in boiled water. If we subtract this value from total hardness, that is 1000 into V2 upon V1. So 1000 upon V1 will be common. Then V2 minus V3, it's a hardness. Then we can find out this temporary hardness. It's a detailed calculation of EDTA method